economic plausibility test, and write that this is a test undertaken. This is a test undertaken to determine. This is a test undertaken to determine whether the observed relationship, is logically defensible, and makes economic sense. Is logically defensible, makes economic sense. Makes economic sense. First of all, a relationship is logically defensible. A relationship is logically defensible if it remains intact. If it remains intact in different samples or situations. In different samples or situations. In different samples or situations. A relationship is said to make economic sense. Is said to make economic sense if it is in agreement. If it is in agreement with what would be generally expected. With what would be generally expected. Is in agreement with what would be generally expected. First stop. A relationship that is logically defensible, a relationship that is logically defensible and makes sense, is said to be economically plausible. Is said to be economically plausible. E.g., labor costs. Labor cost is a function of labor hours. E.g., labor cost is a function of labor hours. Another point is a relationship that does not make sense, and is not logically defensible, is not logically defensible, is known as spurious. Is known as spurious or nonsensical. Is known as spurious or nonsensical. Spurious or nonsensical. Example is intelligence. Intelligence is a function of body size. Intelligence is a function of body size. So yesterday we learned the equation that was between repair cost and what? The data that we read yesterday. It was labor hours and repairs cost, or just hours and repair costs? Labor hours and repair costs. And we got an equation, y is equal to what? The value of A? 1.67 plus 125x. Now this one was obtained from a sample 1, which had how many items? N was 6. Now what we are saying is that in the economic plausibility, we want to see whether the relationship is logically defensible. By defensibility, we mean that relationship remains intact even as you change the samples or you change situations. Specifically, we mean if we were to go back to the same company and gather another sample, sample 2, maybe with 14 items, then we run the equation. Maybe this one we call it Y1 and this one we call it Y2. Then we go back to the same sample, to the same company, we get another set of data, maybe with 28 units or whatever, and then we run an equation, and each of these equations is in agreement with this one. We are getting the same answer. That tells you the relationship is not changing even as you change the samples. Now, for human beings or businesses, we talk of situations. If someone promises you something, do they still remain with that even as circumstances change? And a perfect example is what happens during weddings. When persons are being joined into a holy wedding or whatever wedding, they are told to promise each other some words. I will love you in times of good health, in times of sickness, in times of riches, in times of poverty, and so on. So this person promises that the love they are giving you will remain intact even as circumstances change. Now, such kind of a relationship is said to be logically defensible, and it is good. But if someone was to tell you, mimi nitakupenda only when we are young, tukizeeka kila mtu njia yake. Nitakupenda only when we have money. Ukikosa pesa kila mtu kwao. Nitakupenda, they put conditions. That relationship is not logically defensible. Then we have what we call economic sense. Economic sense has to do with this kind of relationship that you are seeing. Does it make sense? Is it in agreement with what would be expected? And I've always told you that in life we have expectations. Like now that I'm your teacher, one of the things that I don't know, I don't think you expect of me is that I have a girlfriend in this class. You don't expect that I have a girlfriend. So if you are to realize that I have a girlfriend in this class, then that relationship does not make sense because it is not agreeing with what would be expected. Again, looking at me, maybe you expect that I'm married. So if you realize that I'm actually married, that will not get you at a what? At a surprise. Because what you are expecting is in agreement with what you have seen. So if a relationship agrees with what we are expecting, it is called, it is said to make economic sense. So those relationships that satisfy logical defensibility and economic sense, they are called plausible, and a very good example is this one. But the ones that do not, we call them what? Spurious or nonsensical. Nonsensical. Then down there you write that the relationship between labor hours and repair costs. The relationship between labor hours and repair costs in the above case, is economically principal, since the observed relationship is direct, into brackets positive 125, is direct. The observed relationship is direct, and the expected relationship is also direct. And the expected relationship is also direct. Yeah, so what we saw when we read the equation, it was direct, positive sign. Then, under normal circumstances, we would expect a direct relationship. So that is in agreement, and it is okay. From there now, let us look at the next category. The next category of tests, which we say they are called goodness of fit tests. 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 And we write that these are tests undertaken. These are tests undertaken to judge how well. The equation fits the data. To judge how well the equation fits the data from which it was developed. The equation fits the data from which it was developed. The tests are divided. Tests are these tests are divided into two. You see that? The last two things oh, the tests are divided into two groups. 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 So group one inaitwa tests for the whole equation. Tests for the whole equation. Tests for the whole equation. The first one under that, huwa inaitwa coefficient of determination. Coefficient of determination. Coefficient of determination, R square. Number 2, huwa naitwa standard error of estimate. Standard error of estimate. SE. Standard error of estimate. And number 3, huwa inaitwa F test. Then the second category, huwa inaitwa tests for the slope. Test for the slope. So in the test for the slope, wa kwanza anaitwa correlation coefficient. Correlation coefficient. Correlation coefficient R. Wa pili anaitwa standard error. Standard error for the slope, SB. Standard error for the slope, SB. And wa mwisho huwa anaitwa T test. T tests. So those are the tests of establishing how well the equation fits the data. So that the ideally what should happen is when you give your data to a consultant to go and study and then advise you on how you can use the data to forecast, we expect him to run through the data and come up with the equation. But it can happen, this guy does not take the pain to do that. He just goes and idles around, then on the day of the meeting, he comes up with cooked values, in quote. Then when you start using that equation, you find it is complete, it is giving you figures that are far away from the expected values. So before you use, you need to check whether the equation fits the data from which it was established, so that you don't risk using like with unlike. You don't use data that is not similar to yours. And then something even in our normal relationships. If you are looking for a relationship, then most likely we form those kind of relationships with people who we share similarities. That's all. Including marriages. You don't marry a person who is significantly different from you in terms of even education. That's all. In terms of religion, in terms of at times some of us even obey the tribe, in terms of the wealth that is in your family and their family, and so on. Because they say birds of a feather flock together. Ukichukuana na mtu you are significantly different, your relationship itakuwa na a lot of constraints. If you come from a very humble background and you marry a person from a very rich background, chances are mtakuwa mnasumbuana. Kama umesoma umefika college, uchukue mtu wa class 4, chances are bado mtakuwa mnasumbuana, and so on. Okay. Even in terms of age, that's all. Yes. Ukiachana na mtu like 20, 40 years, chances are bado mtakuwa mnasumbuana. So that's about 50. Now let's start with the first one. Coefficient of determination, R square. Coefficient of determination. R square. Coefficient of determination is R square. Coefficient of determination, R square. And we write that this is used to determine how well X explains Y. How well X explains Y. The higher this value is, the higher this value is, the better the relationship. The better the relationship. A relationship with a value of at least 80%. A relationship with a value of at least 80%. At least 80% should be accepted. Should be accepted. While the one with at least, or rather, while the one with below 60%, while the one with below 60% should be rejected. Should be rejected. It is computed as, it is computed as R squared equals explained variation. Explained variation you divide by total variation. Explained variation divided by total variation. You can choose to multiply by 100 or you can leave it. Now this changes to y predicted minus y bar squared divided by sum of y minus y bar squared multiplied by 100 multiplied by 100. So nataka sasa uende kwa ile table tulikuwa nayo nisomee total hii. Y predicted minus y bar. What total did you get? Hmm? 156. 250. Now y minus y bar squared. Total. 172, 083, 334. So times 100. Times 100. What percent is that? 90.79. %. Interpretation of that. What does that mean? Interpretation. Interpretation. This means that 90.79%. 90.79% of repair costs of repair costs are explained or caused by labor hours. Caused by. When we say explained, we mean brought about or caused by labor hours. Still on the same point, this is a very high value. It's a very high value, and the relationship is acceptable. The relationship is acceptable. And the relationship is acceptable. Naona hiyo imepita 80%. Okay. So let's now discuss this one. Standard error of estimate. SE. Standard error of estimate. SE. Standard error of estimate. SE. And write that this shows the amount of error. This shows the amount of error contained in the predicted value. The amount of error contained in the predicted value. Contained in the predicted value. The smaller this value is, the smaller this value is, the better the relationship. The better the relationship. The better the relationship. It is computed as SE equals an explained variation, you divide by residual degrees of freedom. Residual degrees of freedom. Residual degrees of freedom. And then the whole of this, you get the square root. Is computed as an explained variation. You divide by residual degrees of freedom. And this one is changed as sum of y minus y predicted squared. You divide by n minus k. You divide by n minus k. Divide by n minus k. Where k is called computed parameters. Computed parameters. And if you have k here, k can help you to know format of the equation. format of the equation can help you know what is the format of the equation. So if k is 2, then you are dealing with an equation of y is equals to a plus bx. And if k is 3, you are dealing with an equation of y is equals to a plus b1 x1 plus b2 x2. That is what you are dealing with. So k is called computed as in tumetafuta. It is something that we have computed. It was not originally provided. As you can see, this one where k is 2, it is an equation of this format. And we were originally given the values of y and the values of x. We used them to get the value of a and the value of b. So that means we have 1, 2. That's why we have 2 there. So come an equation kama hii, then you'll be given the values of y, x1 and x2. Usitumie kutafuta a, b1, b2. That's why you have 1, 2, 3. So ukishajua k ni ngapi, you should be able to know the format of the equation. Ama ukishajua format, you should be able to get k. Yeah. So let me say for the above case, SE equals kibia kwa table unisomee this value. Kwa table unisomee this value. Y minus y predicted square total. Hiyo column yenye tuliita era total, the square one. Uh-huh. 334. Good. So we divide this by n. N we know it is those values were how many? There were 6. So n is 6 and k is 2. K is 2 because this is the format of the equation. That's the format of the equation. Then you now give me the square root. You give me the square root. Square root. The 2.9. 62.9. Then down there you write that this value is then used to estimate. This value is then used to estimate the confidence interval. The confidence interval for the predicted value as follows. For the predicted value as follows. Y predicted is y raised to power n plus or minus t 1 minus alpha out of 2 N minus K, those are the degrees of freedom. Then you multiply by SE. You multiply by SE. Multiply by SE. That's what I'll send down there. A 95%, a 95% confidence interval, a 95% confidence interval for the predicted repair costs. For the predicted repair costs, when labor hours are 15, when labor hours are 15, will be hiyo equation yetu ilikuwa 191. 191.67 plus 125, eh? So 125 times 15. Now plus or minus T1 minus 0.05 out of 2, 6 minus 2 multiplied by 62.9. So hii inakuja ngapi? $2,066. 2066.67. So plus or minus T at 0.975 and 4 degrees times 62.9. Did I tell you to change the past papers? Let me see the ones that you have. That they are the For those who are online, I have already sent. This section. So Jesus zingine kama SG tunaposishwa mwalimu akichelewa. Hata unaangalia. Zamani. Zamani tulikuwa kesi. So now everyone has the paper. So you will go to the table that is titled T. Yeah? It's on page 67. That's all. Page 67. And this table is slightly different from some of the tables we are used to. The ones most of us are used to, they have the title of T 0.975. But you can see this one does not have such. If you look at the right-hand side, there are 4 columns. There is the one-tail confidence level, you can see that. Then there is the two-tail confidence. There is 1 alpha and 2 alpha. So what you do, this one is a two-tail. It's a two-tail. And the 2 is this one. You can see this one. Two-tail. So utaenda mahali wameandika two-tail. Then when you go to two-tail, ukifuata hizo percentages, we are doing a 95%. That's all. Tumesema 95%. So ukifuata hiyo row ya two-tail 95%, you can see where 95% is. And below the 95%, sasa ukuje kwa row number 4. These 4. So that now you'll be able to tell me this is 2066.67 plus or minus. What do you find at 95, 4? 2.7764. Good. So multiply this by 62.9. So I hope everyone has seen how we are doing that. So this one becomes 2066.67 plus or minus, if you use 2 decimals, this one is 174.64. You're using 2 decimals. So that means on the lower side, minus 174.64 equals, this is 1892.03. This is the predicted value. And on the upper side, you have 1542.75. We have made a mistake. It should have been 2066.67 plus 174.64. 2240 something, eh? 2241.31. Is that it? So on the upper side, that is how it should be. Okay. So let's now discuss the next F tests. F tests. F tests. And write that this is used to judge. This is used to judge significance of the relationship. This is used to judge significance of the relationship. Full stop. It is undertaken as follows. It is undertaken as follows. So step number 1 is hypothesis. Taken as follows. So the hypothesis. So the hypothesis when inaandikwa null. The null hypothesis, you say the relationship is not significant. The relationship is not significant. The relationship is not significant. And in A, the alternative, it A, write that the relationship is significant. The relationship is significant. The relationship is significant. Step number 2 is called significance level. Significance level. Here you say let alpha to be 0.05. Let alpha to be 0.05. So that is assumed. It's assumed. The third step is called test statistic. Test statistic. So test statistic is given as F is equals to explained variation. Explained variation you divided by unexplained variation. Explained variation you divide by unexplained variation. Unexplained variation, and this becomes R squared being divided by K minus 1, which is thereafter divided by 1 minus R squared. You divide by N minus K. Divide by N minus K. Then F calculated. F calculated, we now substitute. Kumbushe tulipata, was it 90.67 R squared? 0.79. Yeah. So then our R square is 0.9079. That is what we had gotten. Now this one is supposed to be divided first of all by 2 minus 1. By 2 minus 1. Then you divide it by 1 minus 0.9079. Which you divide by 6 minus 2. 6 minus 2. So give me the answer to 3 decimals. Give me the answer to 3 decimals. 39. 0.431. 9.431. Confirmed? And those who are online, Boro and Teresa, make sure you are sending your figures. But I'm sure you will not just log in and go back to bed. Boro and Teresa, I'm sure you are also sending your figures. Confirmed. Okay. So if it is confirmed, we go to the next step, which is called decision rule. Decision rule. Now, decision rule kwa F huwa inachorwa namna hii. This is y-axis. Y-axis. And this is x-axis. X-axis. So here, this is F at 0.05 and 1 and 4. And this one is reject. And this one is accept. Now, now take your F tables. Take your F tables. Go to the F tables. Go to the F tables. You can see the very last, that is on page 68. Yeah? That is on page 68. It says 5% values. Eh? That is because the F tables depend on the percentages. Now, what we need to do, or rather, first of all, that 5% your E is 0.05. Then this one is called the numerator degree. 2 minus 1. E4, it is called denominator degrees. 6 minus 2. Sasa kwa hiyo table, zile ziko kwa the title of the columns. Hizo ziko juu, your numerator. Na zenye zimeteremuka hivi, those are the denominators. So you will therefore go to column number 1 and row number 10. No, not number 10, row number 4. Column number 1, row number 4. What do you get there? Yeah, 7.71. 7.71. I've said that this 2 minus 1 is this one, and 6 minus 2, 4. Then nikasema on the table, you go to column number 1 and row number 4, and what you get there is 7.71. Is that okay, Bro? Good. All right. So to solve it, let's now make the conclusion. Let's make a conclusion based on that. Conclusion. Make the conclusion. So conclusion, we will say, we accept, we reject. When you compare this one, you are supposed to compare this one and this one. This one equals side gun. So we will say what? Reject null hypothesis since F calculated is greater than F critical. F calculated is greater than F critical. That is that 9.431 is greater than 7.71. The critical value is the one that you read from the tables. The one that you read from the tables is called critical. So that 9.431 is greater than. So what does that mean? Meaning of that. Meaning of that is that the relationship between labor hours, and repair costs is very significant. I'm using the word very because you can see that 9 is kubwa sana compared to 7. And a relationship that is significant, in other words, is a relationship that you cannot ignore. And you know, even in our lives, we have some relationships that you cannot ignore. There are some people, because of the relationship you have with them, when you see their call, you can easily ignore. Even when you're not very busy, you don't have to receive it. But there are some others, even when you are very busy, when they call, everything has to stop and you pick that call. So such a person has a significant relationship with you. But you know, we know the relationship is insignificant. Good. correlation coefficient R. Correlation coefficient R. Correlation coefficient R. Borrow, I said we were going to column 1 and row number 4 in the table. That's what we have done to get 7.71. Okay, correlation coefficient R and range that this is used to measure. This is used to measure the strength and the nature. The strength and the nature of the relationship. The strength and the nature of the relationship. First of all, it's computed as R is the square root of R squared. R is the square root of R squared. So our R squared we had gotten 0.9067. So get the square root of this and give me the value. The square root. 0.922. 0.9522. So interpretation of that. Interpretation. This shows a very strong direct relationship. This shows a very strong direct relationship between labor hours and repair costs. Between labor hours and repair costs. Yeah, when we introduce this area to SEMA R, inatuonyesha the type of relationship. So now that it is positive, that's why we are saying a direct term. And then tukasema it also shows the strength. Where we say the closer to 1 it is, the stronger the relationship. So naona hii imekaribia 1. So it suggests a very strong relationship. The other thing that I want you to do, Rudy have fahali imeandika correlation coefficient hapo juu. You write stroke multiple R. Multiple R. Because some computers, when we start interpreting computer printouts, they call it multiple R. So if you want a multiple R, it is just the normal correlation coefficient. Haya, so hiyo haina mambo mingi. Tusonge now tuende kwa standard error for the stroke SB. Standard error for the stroke SB. Standard error for the stroke SB. Hiyo nayo tutaandika hivi. This shows the amount of error. This shows the amount of error contained. The amount of error contained in the stroke. In the stroke. First of all, the smaller this value is, the smaller this value is, the better the relationship. The better the relationship. It's computed as SB is equal to SP is equal to SE. You divide by the square root of sum of x minus x bar, which is squared. Which is squared. Which is squared. Okay, so let's our SE to what pattern was it 63 point something? There's not an error for the estimate. It was 62.9. So 62.9, you divide by the square root of, sasa enda kwa table, niambie toto ya hii, x minus x bar. Ten. $19.89. 19.89. Confirmed, eh? Okay. Then below that, this value is then used. This value is then used to determine the confidence interval for the slope. This value is then used to determine the confidence interval for the slope as follows. B plus or minus T 1 minus alpha out of 2 N minus 1 multiplied by SB. Multiplied by SB. So our B was 125. So plus or minus T 1 minus 0.05 out of 2 6 minus 1. We multiply that by 19.89. 19.89. So this proceeds to become 125 plus or minus T at 0.975 and 5 degrees times 19.89. So that again we proceed to have Need to have. Let us go to the T tables and read the same way to Mesoma, but now tutaenda kwa row number 5. Row number 5 at 95%. What are you getting? 2.5706. Now you multiply by 19.89. 19.89. So sasa hiyo utasema namna gani? 2. Give me to 2 decimals. 61.13. So when you subtract, you get 73.87. And these are the one? 176.13. So that is the confidence interval for the throw. The confidence interval for the throw. Confidence interval for the throw. So let's do the last one. T tests. T tests. T tests. Right, that this is used to test. This is used to test significance of the independent variable. It's used to test significance of the independent variable is the predictor, as the predictor of the dependent variable, of the dependent variable. So that is the T. Let me write that. It is performed as follows. Is performed as follows. Performed as follows. Hypothesis. 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 In the hypothesis, see 8 notes. 8 notes written as X is not. X is not a significant predictor of Y. Is not a significant predictor of Y. HA. X is a significant. X is a significant predictor of Y. Predictor of Y. Significance level. Significance level. We say let alpha to be 0.05. 0.05. Test statistic. Test statistic, we say T is B out of SB. Test statistic is B out of SB. So T calculated would be 125. 125 you divide by SB, tumepata what? 19.89. $6.28. 6.28. Decision rule. Decision rule. So sasa huyu anachorwa namna hii. Ukiwa hapa ndani, you can either say accept or reject. Unaona all insignificant. When you say insignificant, it is the other word of saying what? You accept now. The other word. So you can either be told to, then on this side, you are here, it is the other, you say significant. And when we say significant, we are saying we reject now. Saying we reject now. Now ukikuwa huku, again the same thing, significant. Significant. So we are saying again, reject now. Whereby this will be minus T at 1 minus 0.05 out of 2. And the degrees of freedom will be 6 minus 1. And then this is plus T 1 minus 0.05 out of 2. 6 minus 1. And this is the value we have just read in the other working. Ukapata 2.5706. So this is minus 2.5706. And this is plus 2.5706. So this is the most common test that you find in your paper. It's the most common, the most likely that they will bring your way. Okay, so what do we conclude? You see our calculated, this one. So we will say reject null since T calculated is greater than T critical. That is 6.28 is greater than 2.5706. 6.28 is greater than 2.5. And that is what you conclude. What does it mean? What does that mean? So the meaning is, andika hivi, labor hours are a significant determinant. Of repair costs. Significant determinant of repair costs in the above case. Yeah, so those are the 6 tests for the goodness of faith. The 6 tests for the goodness of faith. So sasa, we say there are 3 categories. Let us go to regression assumptions. Regression assumptions. Regression assumptions. Regression assumptions. So the first one is called linearity assumption. Linearity assumption. Linearity assumption. Right, that. According to this assumption, the relationship between X and Y the relationship between X and Y will portray a straight line pattern, will portray a straight line pattern when plotted on a graph, will portray a straight line pattern when plotted on a graph, and the equation obtained will be of the form y is equals to a plus bx. Will be of the form y is equals to a plus bx. It is therefore tested in two ways. It is therefore tested in two ways. One, plotting the values on a graph. Plotting the values on a graph. The second way, developing a function for the data. Developing a function for the data. Then down they write that in the above case, the relationship between, or you can just say the relationship is linear. The relationship is linear. The relationship is linear since the equation obtained, comma, y is equals to 191. It was 191.67. Y is equals to 191.7 plus 125x, comma. Since the equation obtained, y is equals to 191.67 plus 125 is of the form y is equals to a plus bx. Is of the form y is equals to a plus bx. Good. I think we can take a break of like 15, 20 minutes so that we are able to come back by 8:30. We should finish at 10 or 10:30. 10. Okay. So we'll be back at 8:30 and then proceed from there to 10.
Lakini taanguka hiyo tendo la kwanza, computation si obvious utatumia hiyo kama umeifanya logically pale ndio shida.
Blackboard unaona clear. Nakuja kujaribu kuangalia. Sasa inakuwa by balance ambapo ndio kabisa tunasema. Kwa ndio tunasikia kwa inakuwa creativity. Maybe how many hours was zero. Maybe nilikuwa kile kamera ya media Facebook kwa kana ni kamera hii ulipata zile notes mwalimu wa chini zimesema kwa Hizi class watu wanaelewa mbele shule ya kuingia iko kwa Ukiangalia ni mtu mmoja ndio mbaya. Kama sasa kufunga kama sisi shule ikafungwa kurudi nyumbani na kupata badala ya So this is we can extend it. So wait a second.
So we can proceed. Assumption number 2. Number 2 inaitwa zero mean for the error terms. Assumption. Zero mean for the error terms. Assumption. Right, that this states that the sum and the mean, of the error values should be 0. Of the error values should be 0. That is E bar equals sum of the PIs you divide by N, which should be 0. You divide by N and you get 0. And you write that if a non-zero value is obtained, it should be judged subjectively. Or using a significant test, whether it is different from 0. Whether it is different from 0. For the above case, E bar equals, give me the total that we got for this column, E, the error values, in the column to the error. Total yake, my 9 minus 0.02. So you divide this by 6. It must be a very small value. Minus 0.003. So according to this assumption, we should have gotten a 0. So that when you divide, you get 0. But there are times you will not get a 0, like now this one. So if you don't get a 0, you are supposed to judge whether this one is different from 0. And how you judge it is by looking at the values of y. Like the first value of y was what? The first value of y, 600. So if you look at those values in a 600 and the others, when you compare with this, is this anything? Can we say this is 0? Yeah, too small to be anything compared to this. Yeah. So that's what we mean by subjective judgment. Okay, number 3. Constant variance. for the error terms. Assumption. Constant variance for the error terms assumption.
Sorry, no. If you didn't keep this from far away, no one. Okay. Hatuko tumeandika anything other than this. Okay, so then we write that this states that the size of the error values, does not depend on the values of x. And should therefore have a constant variance equal to 1. It should therefore have a constant variance equal to 1. It is tested by visual inspection. Or visual inspection, or by plotting a graph, or by plotting a graph. Yeah, so let us go to the column of the errors. Let's go to the column of the errors. If you look at those values, and you look at the values of x, can you say they are depending? First of all, do we have some values of x that are equal? Yes. Do they have the same errors? No. So if they don't have the same errors, that tells you that they are not depending. But if the errors are depending on x, where x's are the same, we should also have the same errors. That's what we call visual inspection. Kama hakuna zenye zinafanana, you look at like the first value of x is 4. Hiyo ingine ni 5. So zimeongezeka. When you look at their errors, have the errors increased from the first to the second? Yes or no? It has increased. Then the third value of x is 3. And so they have come down. What about the error? Has it come down? It has remained the same. So it has not come down as the x is coming down. So that tells you they are not dependent. Lakini kama ukiona they are moving in the same direction. X zikiongezeka, error inaongezeka. Ama zinaenda in the opposite direction. As in x zikiongezeka, error inapungua. Because that's also a relationship. Right? Remember tulisema there are two types. It is either direct or inverse. Kapate yenye unaona zinafuatana hivyo. So maybe we make the comment there. The errors in the above case. The errors in the above case do not depend on the values of x. Do not depend on the values of x. Hiyo ndio inaitwa visual inspection wenye tumefanya kuangalia kwa macho. Then kama ni hauoni vizuri, ama they appear inconsistent, unachora graph values of errors hapa na x. Then unachora hivyo. Sasa graph itakuonyesha vizuri, itatoa hiyo pattern vizuri. There will be no doubt about it. Haya, hiyo ingine inaitwa normality. Normality for the error terms. Assumption. Normality for the error terms. Assumption. Normality for the error terms. Assumption. This states that the error terms states that the error terms have a mean of 0, and a standard deviation of 1, and therefore follow a normal probability distribution. And therefore follow a normal probability distribution. A normal probability distribution. First of all, it is tested by computing these values. It is tested by computing these values. Computing these values, or by plotting a graph. Or by plotting a graph. Yeah, so sasa hiyo, it is just a summary of the first two, this one and this one. Hii ilisema we have a mean of 0, na hii imesema we have a standard deviation of 1. So if you remember your QA, then you know that those are the cardinal characters of a normal probability distribution. It should have a mean of 0 and a variance of 1. So kama hizi zimekuwa sawa, then it follows that the errors follow a normal probability distribution. So ukitaka kujua whether that is the case, you compute the mean and you compute the variance. Alternatively, kama utaki compute, then we draw a graph. Useme kama inakaa a normal curve. Haya. Number 5 inaitwa independence. Independence of the dependent variable. Of the dependent variable assumption. Independence of the dependent variable assumption. Independence of the dependent variable assumption. Either. According to this assumption, the values of the dependent variable, should not influence each other. Should not influence each other. Not influence each other. That is, there should be no autocorrelation. There should be no autocorrelation or serial relationship. There should be no autocorrelation or serial relationship. First of all, it is tested using Durbin-Watson statistic, DWS. Is tested using Durbin-Watson statistic, DWS, which is equals to 1 minus R. Using Durbin-Watson statistic, DWS equals to 1 minus R. If the calculated value is in the range of 0 to 4, if the calculated value is in the range of 0 to 4, it means there is no autocorrelation. It means there is no autocorrelation. There is no autocorrelation. The above case, DWS calculated equal to 1 minus our R tulikuwa tumepata 9.5. 9.522. 9.522. 0.56. 0956. Then down there you write that this means that, this means that, this means that the values of repair costs, the values of repair costs do not influence each other. The values of repair costs do not influence each other. What we mean by autocorrelation is something like this. If, for example, you are told the values of repair costs, the first one was at 2, then 35, then 38. Are you able to tell the fourth one? The next one will be 41. The next one will be 44. They become automatic. It is an auto. It is what we call a serial relationship. As in, ukishajua the first 2, 3, it becomes obvious. You don't have to look for the others. You can generate them by your own. Now, I want you to go to the sheets. Let's go back to the table. When you look at that table, the values of the repair costs, ukishajua the first 2, 3, can you be able to tell the others? They have no correlation, Yeah, that's what we have found out here. That's what we have found out. Assumption number, that was 5, So number 6. Number 6, Abika, independence of independent variables. Independence of independent variables assumption. Independence of independent variables assumption. And write that this states that, this states that the independent variables in a function, the independent variables in a function do not influence each other. Do not influence each other. Do not influence each other. That is, there is no collinearity. There is no collinearity. And this one is where X is 2. Or multicollinearity. Multicollinearity, this is where X is greater than or equal to 2. Collinearity or multicollinearity. It is tested by computing correlation coefficients. Computing correlation coefficients
between independent variables. Between independent variables. Which are expressed in form of a matrix. Which are expressed in form of a matrix. As shown below. In form of a matrix as shown below. So we have x1 here, x2, and x3. Hii inaitwa correlation coefficient matrix. Correlation coefficient matrix. So this is x1, then x2, and x3. Something like that. So sasa, in between here 1 and 1, andika 1. The correlation coefficient between a variable and itself is 1. Then hapa where we have 2 and 2, it is also 1. Now 3, 3, it is also 1. Then sasa hapa between x2 and x1, it is R21, R21. Then hingine ni R31. Na huyu naye ni R32. R32. Huwa inaandikwa just one side there, but hata ukitaka kuandika hapa is still okay. These values ndio ziko hapa they are the same, so that's why we don't duplicate. So unaweza andika huku juu ama hapa chini. Then down there we write that the variables are said to be influencing each other. The variables are said to be influencing each other. Influencing each other if the correlation coefficient greater than 0.8 greater than 0.8 greater than 0.8. Greater than 0.8. Then we write that the remedy is to drop off. To drop off one of the independent variables. Is to drop off one of the independent variables. Yeah, so sasa, that is how it's done. I think when we come across a question, we may discuss more.
So those are the assumptions, 6 of them. Now from there, safari bado imeendelea. And now we need to discuss something called interpretation of ANOVA table. Of ANOVA table. Now, ANOVA table is what you get when you solve a regression using a computer. So, I want us to have illustration here. Illustration. So hapa niko na toto inaitwa residual, inaitwa regression, inaitwa DF 1, 3, 4, SS 88, 7.2, 95.2, MSS 82, 2.4, F 36.67, and C 0.00904. Come across a table like that. When you do regression using a computer, you come across a table like that. So point number one. Point number one, this DF means degrees of freedom. Degrees of freedom. Your DF means decrease of freedom. Point number 2, regression DF. Regression DF. Regression DF is the number of independent variables. Number of independent variables. Which in this case it is what? This one. That is the number of independent variables. When you know the number of independent variables, that helps you to know the format of the equation. So format of the equation that we are dealing with will be y is equals to a plus b x. An equation that has one independent variable, it's what we call simple regression. Then the other thing that helps you to know is k. We earlier on came across k, na tukasema if you have an equation kama hii, k is 2. Point number 3 is what we call residual DF. Now, residual DF, they are simply given as n minus k. We also came across them earlier on, n minus k. So this one is 3. It is this one. It is 3. K is 2, or we say K is the computed value. Computed value. If you look at the notes that we had in the standard error of estimate, you'll see it. This one. Okay, now that we know K, this one can help us to argue like this. N minus 2 is equals to what? 3. N minus k equals 3. So that means that if you are looking for n, it must be 3 plus 2, which is equals to 5. Which is equals to 5. So that means you are dealing with a data that has 5 observations. Point number 4 is called total DF. Now, total DF is given as n minus 1. N minus 1. So this is 4. That is 4. And that means when you have it there, it can help you say that n will be 4 plus 1. So that again takes you to, okay. So this again takes you back to n. It takes you back to n. Point number 5 is SS. SS. When you see SS, it has very many names. The first one is sum of squares. Sum of squares, that's the first name. Or you can call it variance. You can call it variance. You can call it variation. You can call it variation. In our notes, we have been using the word variation more. Or you can also call it error. You can also call it error. So when you see this SS, it means sum of squares, which you can also call variance or variation or errors.
Haya. Point number 6 is the regression SS. Regression SS. The short form of the word regression is RG. So regression SS is what we call explained variation. Explained variation. And according to our table, the explained variation is 88. This one, regression SS. That. Then point number 7 is residual SS. Residual SS. Now, residual SS is what we have been calling unexplained variation. Unexplained variation, which is 7.2. We still have how many minutes? That's 2 minutes. So, ukishajua this residual SS, you are able to get what we call SE. In the formula that we had earlier, tulisema SE is unexplained variation, 7.2. You divide by the root of n minus k. And n minus k, it is this one, 3. So give me that. You are able to know SE. You can compute SE based on that. $4.1. 4.16. 4.16. Then point number 8 is total SS. And total SS is simply total variation. Total variation. And this total variation, you get it as the regression SS plus residual SS. It is the regression SS plus residual SS. So if you want to come back and you say this is 88 plus 7.2, that gives you 95.2. Which is this one, eh? When you know this one, when you know this one, it will help you get R squared. Remember, R squared was the explained variation, that is 88. You divide by 95.2. Nine to 4. Equally, it will help you compute R as the square root of 0.924.
0.961. 0.961. Point number 9 is MSS. Now, MSS is called mean sum of squares. Mean sum of squares, and is given as SS, you divide by DF. Mean sum of squares is the SS, you divide by DF. So if you come here and say regression MSS, it should be given as the regression SS. You divide by regression DF, which is 88, you divide by 1, and that should give you what? Sorry, not 1. Should give you 88. So hii tunasema this one ukitaka it is this 88 divided by 1. Yeah. Then point 11 is residual MSS. It is residual SS. You divide by residual DF. Residual SS, you divide by residual DF. This should be 7.2, you divide by 3. Check whether it is giving you 2.4. 2.4. Then this F that you see, it is what in our notes we call F calculated. And this F calculated is arrived at as regression mean sum of squares. You divide by residual mean sum of squares. Regression mean sum of squares, we divide by residual. So Sasa, this is 88 divided by 2.4. Can you confirm whether it gives you that 6.667? Okay. Then number 13 is the C. Now that value that follows there, it is what in the notes we call F critical. It is what in the notes we call F critical. And this one is given as 0.00904. And this one, when you compare now this critical and the calculated, you say the relationship is significant since F calculated is greater than F critical. The relationship is significant since F calculated
greater than F critical. So this understanding is important on top of what we have been discussing, because you will get two types of questions, or two types of questions. One is to interpret these values, to tell us what they are. The second type of questions that you can get is where some values are missing. Where some values are missing, and you are told to look for the others, for the other. Like now, you can see most of them, they have a relationship of 3. You see, these are 3 values. So if you are given 2 of them, you should be able to get the other one. And the same case applies. The same case applies. So, based on that, I want to give you an assignment on the same. Assignments. 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 Compute the missing values in the following tables. Compute the missing values in the following tables. So we have regression, statistics, statistics. How do you know that? Statistics. I mean, joke, right? Statistics. Is it like that? Huh? Star? I'm gonna TI. Statistics. Evil. No. Oh. You should be going home now. Star?
Yes. IS.
IS. Namna hiyo. Creation statistics. We have the value here. Kwanza ni multiple R. This is R squared. R squared is x1. This is x2. Variance is x3. Observations. Observations are the other word for the sample size. They are 18, 19. Bring them together. Then hapa inaitwa ANOVA. So ANOVA we have regression. We have residual. And we have total. So what DF we have X5, X6, and X4. Let me delete this one. X5. So this is 1. This is 1. So make this one to be X5. X5. Oh, hatuna 4 Lakini ushaandika. So wacha ikae tu hivyo. Let me not delete so much. The next one is SS. SS tumepewa 14.246 na hii ni 45.893 na hii ni 60.139. Then MSS, this is X7 is missing. This is X8 which is missing. Then we have F which is X9. And then we have C which is Z. So on your own, I would like you to get those values. Get those values. That is later on. Still, I have like 10-15 minutes. So you can allow like 10 lines. They should be enough. 10 lines to do that. Let us do something small here to memorize hii. Called of table coefficients stroke estimates
table of coefficients, stroke estimates. So we have illustration. So in the illustration, so we have the coefficients, or let me just call it slope. This is intercept. Call it liquidity. So we have coefficients. Coefficients, I have 0.55, 851, 0.04375. So standard error is 0.018707 and 0.001842. Then we have T statistic 29.8554. This is X1. P value stroke seed 0, 0. Then we have ROA at 95%, 0.52182. This is X2. Then we have upper at 95%, 0.5952, and this is X3.
Okay. Point number 1 is the coefficients. These coefficients, they are the computed values. Computed values together known as slopes. Known as slopes. B. So these ones, they are the computed values. So we are saying they are together known as slopes because this one is the intercept, which you do not call slope under normal circumstances. So sasa ukiangalia those values, they give you the equation y is equals to 0.55851 plus 0.04375x. Ukiambiwa uandike equation, ni hizi values unachukua. Kama zile tulikuwa nazo kina 191 na 125 ndio hizo. The second point is ukiona standard error hapa. Standard error, it is what we have been calling SP. It is what we have been calling SP. Point number 3, the so-called T statistic. T statistic, it is what in our notes we were calling T calculated. And this T calculated, we said it is B, you divide by S, B. That is the formula that we gave. B, you divide by SB. So consequently, this X1 that is missing, this X1 that is missing, it should be arrived at as B being 0.04375. You divide by 0.00184. So that X1 that is missing. Mm-hmm. 23.75. Yeah. So if you are to come across any now of those values that is missing, this is B, this is SP, and huyu mwingine, that is point number 4, huyu mwenye anaitwa P value or C, it is simply plus or minus T critical. It is simply plus or minus T critical. Ile tulikuwa tunasoma kwa table. Ndio hiyo. Then the limits are arrived at as B plus or minus T 1 minus alpha out of 2 N minus 1 multiplied by SP. Una formula tulisoma kama hiyo eh? Yeah, so the limits. Thus, for X2, hii ukiweka utapata both X2 na X3. Hapa anderua So hii nitakuachia utajipanga nayo hivi. The slope ndio hii 0.04 375 plus or minus T 1 minus 0.05 out of 2 and and this question is 1819. Times the standard error is 0.001842. Maybe you need to specify this n, this 1819 is in the previous table. Hiyo swali table iko hapo juu. Hapo ndio inapatikana hiyo n, the previous table. So here it will be 0.04375 plus or minus. Ngoja kwa table usome hii. Sasa hii utasoma kwa 1000. Is it so? Kwa sasa hii imepita. Is it 1000? Hiyo T tables. Huh? At that. Unastahili kusoma the T tables. Oh, the highest one ni 30. Okay, sawa. Nasoma kwa hiyo at 95, 2.02. Okay. Hiyo ya mwisho. Ukipata a figure greater than the table, unasoma hiyo kwa karibu na 30. So ukisoma hiyo unapata 2 points. 0423. So times 0.001842. That is how it's read. That's how it's read. Okay. So you will solve that on your own. So we call it at that point. So next time when we meet, please remind me to solve one question, one past paper, because now my head has registered to memorize your topic or that area. So if you don't remind me, I might come and do something else. So when we meet next, we should do one past paper question to crown that. Now there is a slight change in the timetable. There's a slight change in the timetable because Mr. Karoa will not be able to continue teaching you SGE. Will be taught by Mr. Mwendwa. You met Karoa once, eh? Yeah, so there will be Mr. Mwendwa, and the timetable has changed. So tomorrow morning you will have SGE, not BMA. Yeah. I posted in the group. So you'll be able to see that. Thank you so much. We meet in the next lesson.